Welcome to 9.2b. We're still talking about special right triangles. In this video, we're focusing on the 30, 60, 90 triangle. This one is a little bit more complicated than the 45, 45, 90. So give yourself some grace, be patient. It might take a little while to get used to what we have to do with these triangles. But once you get it, you got it. You're good to go. Okay, so in a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg. So that's what this formula is saying here. That's also what this diagram over here is saying. So your hypotenuse is represented by 2x, and x is just that shorter leg. And then the length of the longer leg is rad 3 times the shorter leg. So that's written out here in that wordy formula. Over here in the diagram, they're saying your longer leg is x. X is that shorter leg times rad 3. So use whichever of these is going to be helpful. If you prefer these wordier formulas for now, use them. That's totally great. Eventually, I want you to be able to use this diagram to help you out. So we're going to do a few examples and just try to get a little bit more comfortable with what we need to do here. Remember, the whole goal of these special right triangle theorems is to kind of give us some nice little shortcuts, honestly, when we're dealing with these triangles. Every single 30, 60, 90 triangle has these relationships between sides. So instead of always applying the Pythagorean theorem, always having to solve for these other sides, use these ratios and relationships to help you. It'll be a little long, maybe a little uncomfortable for the first few problems that you do, and then eventually it'll be so much easier than using other methods. So just stick with it. You got this. Here's our first example. They're asking us to solve for y and z. First thing is, okay, they're giving us one side. We know that this side down here is 7. We want to figure out, do I know my shorter side, my longer side, or leg, sorry, shorter leg, longer leg, or my hypotenuse? Well, I know my shorter leg because I'm right across from that 30-degree angle. Our hypotenuse is y, and our longer leg is represented by z. And I want us to try to use the diagram to help us out as much as possible. So our shorter side is represented by x. Our longer side is x rad 3. Our hypotenuse is 2x. So I know here my shortest side, x, equals 7. That's given information. Z, that's my longer leg, so that's x rad 3. Well, I know what x is, so I can just plug that in, 7 rad 3. Boom, we solved it. That's what z is. Y, that's my hypotenuse. That's represented by 2 times my shorter leg. 2 times 7 is going to give us 14. So y equals 14. So all we're doing here is we're using this theorem as kind of a shortcut to help us determine missing sides based on just one of those sides. When you know your shortest side, you can literally just take that value and plug it into x rad 3 or plug it into 2 times x. It gets a little more complicated when you're given the longer leg or the hypotenuse, so that's what we'll do in the next couple of examples. Get used to radicals. We're going to deal with a lot of radicals in this section, if you couldn't tell already. All right, so for this problem, we're given a different triangle. It's still 30, 60, 90, so I can still use those relationships. So I'm going to kind of redraw in the orientation they gave us here. Our shortest side, remember, is x. Longer side is x rad 3. Longest side, or our hypotenuse, is 2x. And here they're asking us for the value of d in simplest radical form. So first things first, that 5 that they're giving us over here, which side do we know? Shortest, longer leg, or hypotenuse? Well, we know our longer leg. So I can say that 5 equals x rad 3. Remember that x just represents any number. And I can tell over here, well, they're asking me for d. D is that x value. D is representing my shortest side. X represents my shortest side. So you can think of this either way, right? You can think of this as 5 equals x rad 3, or you can say, well, 5 equals d rad 3, and they're asking me to solve for d. D and x are representing the same exact thing for this problem. So if you wanted to, you could go ahead and say, okay, well, 5 equals d radical 3, my shortest leg times radical 3. So if I want to solve for d, I need to divide both sides by rad 3. So I'm going to get d equals 5 rad 3. Remember, I don't like that radical in the bottom. I need to rationalize the denominator To do that, you're going to multiply by radical 3 over radical 3. Up top, I'm going to have 5 times rad 3. Can't really combine those. On the bottom, remember, radical 3 multiplied by itself is just going to give us 3. Can't really simplify any further than that, so this is actually our final answer. D equals 5 rad 3 over 3. And that might look a little bit ugly. If it was like a real world application, then yeah, you would want to throw this into your calculator. That would be a lot easier to deal with. But in the math world, this is our simplest radical form. We're going to leave it alone. That's your final answer. All right, I have one more problem for you. It's our final example over here. We're dealing with a pendant. It's in the shape of an equilateral triangle. So if I'm dealing with an equilateral triangle, what would each of my angles be? Hopefully you said 60. So I know each of these angles is 60 degrees, each of these ones. If they're cutting the pendant exactly in half, they're telling us that the height of the pendant is 18. Well, I'm dealing with a perpendicular bisector there, so I must have cut this top angle exactly in half. So I'm dealing with a 30, 60, 90 triangle. They're asking what is the length S of each side of the pendant to the nearest tenth of a millimeter. Basically, plug your final answer into a calculator and round to one decimal place. So I'm going to just redraw the triangle that we're looking at over here. They're asking me to solve for S, which is the hypotenuse. They're telling me this side is 18 millimeters. That side represents your longer leg. So to find my hypotenuse, remember that your hypotenuse, if you're dealing with a 30, 60, 90, is 2 times your shorter side, your shorter leg. So that would be down here. So to figure this out, you're going to use your longer leg to solve for your shorter leg. Use your shorter leg to help you find your hypotenuse. So just to kind of switch it up, I'm going to use the wordy formulas for this. I know my longer leg equals radical 3 times my shorter leg. So I could say 18 equals, well, my shorter leg is x times rad 3. Let's go ahead and solve for x. X equals 18 divided by rad 3. We need to rationalize that denominator. Up top, I get 18 rad 3. On the bottom, I just get 3. Well, 18 divided by 3, that's just going to cancel out to 6. So your shortest side here would be 6 times rad 3. That's what your x value is. S, in this case, that's my hypotenuse. So that's going to be 2 times my shorter side, 2 times x. Go ahead and plug that value that we just solved for in there. You're going to get S equals 12 times radical 3. They want us to figure out what this would be to the nearest tenth of a millimeter. So when you throw this in your calculator, you're going to get S is roughly equal to 20.8 millimeters. That would be your approximate answer. All right, so stick with these. I understand 30, 60, 90, and 45, 45. They can be a little tricky to get at first. You're going to have a few worksheets to work on. If we're still feeling a little confused about any of these problems, help each other out. I know you all can figure these out. You're all very smart and wonderful people. And look stuff up on YouTube, right? That's a huge resource for you. If you look up special right triangles, 30, 60, 90, you'll find tons of resources there. Email me with any questions, please, please, please. And otherwise, you'll get to watch another lovely video tomorrow. So I'll see you next week. Please email with questions. Have fun with the homework. Bye.